In this video, I want to demonstrate how to conduct one-way repeated measured ANOVA test in HAB. Here are the steps to follow. Step 1, we estimate the descriptive summaries of the variables. Step 2, test for the normality of the variable at each time point. Step 3, test for homogeneity of variances of differences between all combinations of time points. Step 4, conduct the one-way repeated ANOVA test. Step 5, conduct the post hoc test, that is if this test is significant. Then step 6, we are going to interpret the exercise if the test is significant. That is if the test here is significant. Okay? Alright. So the non-hypothesis we have before us is this. There is no significant difference in self-esteem scores across time points. Alternatively, we can also state the non-hypothesis in this way. Time does not have a significant effect on self-esteem scores. And the data set we'll be using is called self-esteem data. So I've already set my working directory. Let me import data set. The data set is imported. I may want to view the data set. Let me view the data set. The data set. So we have same esteem score at time 1, at time 2, and time 3. So you can see that this data set is in a short format. So we need to first convert it to a long format before we start our analysis. So to do that, we are going to use the function gather that's available in the tidyverse package. So I will need to load that package. No, it's not loaded here. Library tidyverse. So now let me convert that. To convert that, I'm going to convert. I have this. Let me view this data set to be sure that it has been converted to the long format. Yes, that's been converted to long format. You can see we now have time grouped together, T1, T2, T3, okay, for 10 people. Then for T2, for the same 10 people, T3 for the same 10 people, and have their respective scores here. So this is long format. Then we fill the data set, okay. This is already written here. So the next thing, I want to attach the data set. Let me attach data set. Then I want to start the analysis proper. The first thing is descriptive statistics, and I'm going to use the library psych library. Okay, and the function I'm going to use described by is available in the psych library. So let me load that. Then to do that, I'm going to score then time for each of the time points. So I run that. Descriptive statistics for period 1, the mean is 3.14, for period 2, 4.93, for period 3, and we have 7.64. We also have standard deviation for time 2 and time 3. Okay, we want to see if there are outliers. If there are outliers, so to do that, we are using box plot. Box plot. I mean, the function we are going to use here is box plot function. So the first argument is score and followed by the time variable. So we run that. You can see for time 1. For time 2, we have an outlier there, only for time 2. For time 3 and time 1, no outlier. So the next thing, we want to check for the normality of the variable at each time point. So how do we do that? We are going to use the function ggquickplot available in ggpub HAB package. So the first argument here is the data frame itself. Then the second argument will be the score, that is the dependent variable in this wise. Then parset.by, that is time variable. So let's see. So we can see for time 1, this is normally distributed. Also for time 2, normally distributed, and for time 3, also normally distributed. All those seem to be normally distributed. So let's use format test to confirm that. Use by function, then the name of the dependent variable here. We have factor, time factor, that is time as the factor variable. Then we have the name of the test. So we can see for time 1, this is greater than 0.05 normally distributed. For time 2, also normally distributed, and for time 3, normally distributed. So the assumption of normal distribution for each time point is satisfied. So conduct a one-way repeated ANOVA test. So to do that, we need a package called R-statics. R-statics. Okay, so let me do that library. Statics. So now load the library. Yes. The function we are going to use is another power underscore test, and the first argument is going to be the name of the data set, the one that is available, that is converted to long format. Then I have dv, that is dependent variable, that is score. So and then we have with, that's ID. We want to put ID there, so that how we recognize it as it's a repeated test I'm carrying out. Then we say within is going to be time. Within, that is time. Then we assign the result to this repeated and measure underscore ANOVA, because we still want to use it. So we run this. So the test has been run. We need to test for we want to check for sphericity. Okay, we do not expect to reject the non-hypothesis of Marshall test for sphericity. If the test is rejected, so we are not going to use our usual result. The result we are going to use is sphericity correction result. Okay, let's check for sphericity. So to do that, we are going to use. So let me type it right from the beginning. So what we are going to do is that we are going to copy this. Let me paste it here. Then if I put $sign here, it will give me options, whether it's another result I want, or sphericity result I want, or sphericity correction. So sphericity test first. You can see the test here is p-value is greater than 0.05, so I cannot reject the non-hypothesis of Marshall test for sphericity. So we are happy the assumption of sphericity is met. So since the assumption of sphericity is met, so we are going to view the ANOVA result. To view the ANOVA result, we are going to copy this, so then $sign, so we pick ANOVA. So let's see the ANOVA result here. So this is the ANOVA result. Is significant. So this means that there's a significant difference in self-esteem score across time points, and the effect is large. So let's check sphericity correction. So this result is only used if Marshall test for sphericity result is significant. That is, if we reject the non-hypothesis of sphericity. Because we not reject the non-hypothesis of sphericity, so we are going to interpret this our result, this ANOVA result. Okay. If the result of sphericity is rejected, we have interpreted this result. This result, that is p-value. Okay, we have to test. We have interpret C for each first. So we have p-value less than 0.05, and for GT test we have p less than 0.05. Okay, but since our sphericity result is not significant, so we only stick to this result. So we don't need this result.